All right, so today we're doing test preparation, and we're gonna look at a test paper, common test paper from it's KZN Physical Science. Common test, ne? 2022, ne? Agree, you said you are writing on the chemistry part, ne? So we'll look at those questions and then, yeah. We'll skip the multiple choice for now, and then look at the chemistry. Okay, so question 5 has a nice question. All right, let's start question 7. Yeah, let's do question 7. So we are given that phosphoric acid H3PO4 reacts with water through a 3-step reaction. It's this computer. I can tell you what's wrong with it. Something kamogara. I need to go take it in for repairs. But just bear with us. I'll speak loud now so that you can hear me over there. There's thing that sounds like a engine. Okay, so here you get asked questions like why is okay, so in a 3-step, okay, so let's start here. Phosphoric acid reacts with water. Water is H2O, and this is a 3-step process, ne? So it's a 3-step reaction process. You can still hear me again? Hello? Okay, good. So are you able to look at Jamboard on your side? Jamboard on your side. Can you see Jamboard on your side? Jamboard. Can you see Jamboard on your phone? Okay. And then I've shared the screen here, this question paper. Can you see it as well? Yeah, you can see it. Okay, which one should I share? You're not sure. Okay. It's fine because the notes that I'm writing more Jamboard, you're gonna get them anyway. But I want us to look at. Okay, we can see there is this question paper, ne? What I'll do is I'll switch between this screen and Jamboard like so, ne? Yeah, whenever I switch, we'll do that. Is that fine? Okay, cool. So for now, the question tells us that we have phosphoric acid reacting with water in a 3-step process. So step 1 is as follows. We have H3PO4 plus H2O. It's a reversible reaction. It gives us H2PO4 plus H3O plus, ne? And then in step 2, we've got that H2 PO4 H2PO4 plus, oh, it's minus up there, plus H2O, also reversible reaction, and it gives us HPO4 to the -2 plus H3O positive. And then step 3 gives us HPO4 2 minus or -2. Let me just put it as 2 minus instead. Plus H2O. It's a reversible reaction and it gives us a phosphate ion plus H3O. Ne? So the first question, ne? 7.1.1, ne? Why is H3PO4 a Lorry-Bronsted acid? Why do you think that is? Yeah. Magdalene?
Sure.
Why do you think H3PO4 is a Lorry-Bronsted acid? What is a Lorry-Bronsted acid?
I don't have definition. Marie is about to water. Acid a proton donor, then base a proton acceptor.
Oh, good. So Lorry-Bronsted acids donate protons. That's very good. And it's therefore, and H3PO4 is a proton donor. Therefore, it is a Lorry-Bronsted acid. That's fantastic. Well done, eh? You did well. Did very well. Did very well. So there, we create 2 marks, ne? Then the second question, define ampholyte. What is an ampholyte?
Ampholyte.
Yeah, ampholyte. What is ampholyte? You're not sure. Okay, it's fine. We can both think about it. You remember those substances, very amphoteric, where amphoteric can react as either base or acid. Remember that? Amphoteric, where they say a substance that is amphoteric can react as either an acid or base. You remember? Substance that can act as either base or acid. You remember that definition? So ampholyte or amphoteric substance. So amphoteric is the type of substance, but ampholyte is a term that describes the substance. Ne? So ampholyte is the same as an amphoteric substance. So an ampholyte or amphoteric substance is a substance that can act as either acid or base. Ne? So either acid or either base. You remember that, Mus? We talked a little bit about that last time already, acids and bases. Ne? So, but here's a tip. If you see ampholyte in a question, it's the same as amphoteric substance. Ne? So I'll just, let's do this. Yeah, so ampholyte is the same as amphoteric substance. Ne? So for correctly identifying those, you get your 2 marks there. Ne?
Oh, okay. So, pala butisha. Ano kara? Nama kayo. Ano kara kim is a substance that acts as either acid or base. Isha.
Yes, you are correct. 100% correct. Kamho correct 100%. Wa khoja 2 marks ao kamoka one. Because what they want to know gore, can you identify gore ntwe ba nyakang we tseba go tswa wena ke this part ya go ba le ampho or amphi mo go yona. And ampholyte le amphoteric substance, it means the same thing. But the base definition ya ampholyte or amphoteric substance ke yona e fetsang go bolela ya can act as acid or base. Wa gusha. Wa gusha.
Yeah,
All right. So Gamkhowe, you are 100% correct. You will not get penalized for using if or as or act. Those specific words like these ones. Who can act. You know those things. I don't think you'll get heavily penalized, Katson. So don't be afraid of that. The main idea is that you can tell whether an ampholyte or an amphoteric substance can act as either acid or base in an acid-base reaction. That's what they want to know. But the important thing is ampholyte is a bit outdated. So amphoteric substance is what's usually used in the thing. At least that's what this learning guide is suggesting. So I'll stand to be corrected. But ampholyte but amphoteric substance is used mostly. And this is what I'm getting from the learning guide. But if there is some other source erring, you can still use ampholyte and it's fine. By all means, use it. Because why would it be examined? And this question paper is from 2002, so I guess it's still in use, this word. Or unless they are testing whether you are aware that ampholyte and amphoteric substance are one and the same thing, even though ampholyte might be known to be old school. But anyway, 7.1.3. Let's do number 7.1.3. So, in that reaction, this reaction, H3PO4. Remember this reaction, So, we must, I get first. Yes. So we must identify two substances that act as ampholites in the reactions above. So step 1 is reaction amatomo. We need to identify which one is an ampholite. Ne? Step 2, we need to identify which one is an ampholite. And step 3, we need to identify which one is a ampholite. So we must find two that act as ampholites. So we get 1 mark for each. So substance yamatomo, which one would you say it is?
It is an AX ampholite water.
In this reaction, it will be water. Why do you say that? Why or so? Why or water?
Because water is a base or proton acceptor.
Okay.
Step number. Yeah, go.
So it acts as protein receiver or acceptor. Okay, that's good. And then substance abobedi. This one. It's not make sure. I like your honesty. I like your honesty. It's fine. What we're gonna do, we can discuss it. Ne? We can discuss it because I agree we know the definitions of what a proton receiver is or a proton donor is. Ne? I'm just waiting for something. Okay. So I agree amphoteric substance can act as either base or acid. Ne? So from this reaction, here, this is acting as a base, I get. So it receives a proton and then it becomes something else. In this reaction, we've got this one donating a proton to become that, and this one also receiving a proton to become that. I get. And in this reaction, we also have this one. In the step 3, we have HPO4 to the negative to the 2 minus plus H2O, and it gives us a phosphate ion that and H3O plus. Ne? Now those are for the forward reactions. These are the forward reactions, the reactions going from left to right. If we are considering going from right to left, what does it tell us about these two? If we're going to go from H3O plus PO4 3 minus to get HPO4 2 minus plus H2O. If we are going in the reverse direction, what do these become? Maybe let me go back to this screen. So if we have these two reacting to give us these two. Again, this sign tells us that the reaction goes forward and it also goes in reverse. Again, so if renally just these two reacting in this direction, which one would be an acid and which one would be a base between these two? If you were to think about it. Oh, sorry, you got disconnected there, Skis. Hey, Magdalene, did you hear my question? Okay, good one. So, reaction sign here, this sign in the middle, ne? It tells us that the reaction goes from left to right. This symbol here. I want a circle and this symbol. You see it? Sitlogile.
So I get to know why because
Is it? Yo, it's gonna slow us down, this network. It's gonna slow us down so bad. So bad. Anyway, Kibekere, this symbol here, what is it showing now? You want to share your screen? Okay, share. Share, I'm not seeing your share screen. You wanna feel that logo ya go ba le M? Okay, you know what you can do? I give on Jambo. I can share anything now on my side. You know what you can do? It's fine. Restart your Google Meet and then join again. That could also help. Yeah, Izame. And then restart Google Meet.
I'm back.
Yay, welcome back. Welcome back. Welcome back. Alright, so is it showing anything that's sharing? Or oh no, I haven't shared anything. Share. Okay, is it sharing Jamboard now? Eh?
It's a loading.
It's loading. Okay, it's fine. Alright, so it's showing now. Ne? Okay, so can you see the symbol that I'm circling around? Ka highlight, that one. Ka laser point. Eh? This symbol. Oh, that's a good question. But I'm surprised you're not aware of Iraore, but I'll explain. What this symbol tells us, ne? It tells us that on the left-hand side of that symbol, we have two reactants that are going to combine, and in the left to right direction, ne, we will get these products. Ne? But also, if we take these two products, oh, okay. So this symbol means that this reaction is reversible. In other words, reaction A, how is reactant A plus reactant B? Di tlo tlhakana tša go fa product A and product B. That's what it means for this half, the arrow going from left to right. Then for the arrow going from right to left, it means that these two products are also reactants that give us these products which were the original reactants. Waigwisha. You get it?
Not really.
Not really. Oh, okay, it's fine. So this symbol ne, tells us that the reaction is reversible. Ne?
Oh, okay.
Is reversible. And what that means is that the reaction can go in this direction. These two reactants, ne? Reactant A and reactant B will combine and will give us product A and product B, or product C and product D. Ne? That is in the forward direction. So the above arrow means forward, and the below arrow means reverse. Ne? So these two reactants give us these two products in the same way that these two products will be able to give us the initial reactants. Is it better now?
Yeah, that's okay. Yeah, thank you.
Okay, that's great, because it's a very important thing to understand, and it will share with other things, including up until grade 12, because if you master it now, then you'll do well in grade 12. But anyway, the point is, I guess we were looking at for ampholites or amphoteric substances in all of these three reactions. So now I'm saying to you, now we identified substance 1 as H2O again. But now I'm saying H2O can't be the only substance because these reactions go forward and in reverse. Therefore, in the reverse direction of each of these reactions, there should be ampholyte as well. Can you understand why?
I know the answer for the other ampholyte.
Okay. So which substance?
So I think the yeah?
A nominate a substance as ampholyte.
I think so. Mara ke rana ka ke ya step 2 H2PO4 ya ba di negative for di inagana sa kisho.
Okay. Okay. So the ampholytes are totally circular blue, ne? We've already said it's H2O. It's fine. H2O. It's fine. H2O is also fine. So that means in the reverse reaction of step 2, then H2PO4 can also be an ampholyte because if we look at this reaction going from right to left, step 2 reaction going from right to left, then we've got H3O plus as an acid and HPO4 2 minus as a base. Yeah, so this can also be a base, and also H2PO4
And so is it correct?
H2PO4 is correct, yes, but also
Why?
it's correct because in this direction from right to left, because this one, HPO4 receives a proton from this one to give us H2O and H2PO4. Then if this one receives a proton, then it acts as a base. But in this case, how do I explain it? How do I explain it without for confusion? Okay, so let's do this. This would be, so if we're looking at that direction, this would be acid, this would be base, and then we should have, how did I explain it last time? It was to say, oh yeah, all right, so if this if this one donates a proton and this one accepts it, then in this direction, this one would be the acid and this one would be the base. So this one would be acid and this one would be base. Yes. So eso Magdalene, ne? If we look at step 2, only step 2, ne? Then this one, H2PO4 minus, would be donating an acid, a proton, would be an acid donating because in the product side, this one has donated a proton. So the H2 has changed from H2 to just H, and I'm assuming it's 1 there, right? So that means this one has acted as an acid in this reaction, whereas the water molecule has acted as a base. And then in this, so that we can get these two products, HPO4 2 minus and H3O plus. And this is for the forward reaction. Now in the reverse reaction, we have H3O plus acting as an acid and HPO4 2 minus acting as a base to give us H2O and H2PO4 minus. That means in this in the direction from right to left, then HPO4 was acting as a base. Therefore, we can say you are correct. H2PO4, even though Obogiasa also sure, is both an acid and a base. Do you understand that one, or ke hlalose bos? Ke hlalose gape? Okay, it's fine. So let's start here, ne? All right. In these reactions, ne? In these reactions, renale an acid, yamathomo ke phosphoric acid, ne? Now, since it reacts with water, and this itself is an acid, then the forward reaction gives us this result plus H3O, ne? So what happened? This part here was acting as an acid, and this part here was acting as a base, ne? In the second step, this result, yeah, H2PO4 minus, which in this reverse reaction it would be a base, so that we can get back to the original reactants. In the second step, it acts now as an acid. Yo, ke thoma fast, ne? Ke thoma fast. Okay. Ke hlalosa gape, ne? I'm starting the explanation from scratch. So, initially in step 1, we have phosphoric acid plus water. And that gives us these two products. Now, these reactions are reversible, so meaning the forward reaction happens, but also there's a reverse reaction, meaning the same products can react again to give you the initial reactants. And now we have this in all three reactions, in all three steps. So in the first step, water is our ampholyte because it can act as either acid or base. Oh, no, maybe let me not say that. We initially have the acid and water, which is acting as a base, and then it gives us this ion. So now in this, it gives us these two products. So this product here, H2PO4 minus, in the second step, ne, it now acts as an acid. When it acts as an acid, it reacts with water and it gives us HPO4 2 minus plus H3O plus. So yes, your guess was correct that H2PO4 minus is an acid. So in this case, it's reacting as an acid. But in the reversible reaction, Yamatom, it was acting as a base in the reverse reaction to get the original reactant. So yes, this is an ampholyte. This one is an ampholyte. So that is an ampholyte, that is an ampholyte. Now again, we go back to step 2 and step 3. So in step 2, we have this acting as an acid, reacting with water, acting as a base. And the result is this HPO4 2 minus and H3O, which my argument is in the reverse reaction, this should act as a base, whereas that acts as an acid because it's going to donate the proton there so that we end up with this one. Therefore, this one is acting as a base here, but in this reaction, step 3, it's also acting as an acid, because when it combines with water, it gives us this one here. So yes, there are two ring. These are our what do we call? These are our ampholites, and Yamatomo is this one here, H2PO4 minus, because in this part, because there is a reverse reaction, then it becomes a base to provide the original reactants. But in step 2, it now acts as an acid to react with water to give us this ion. And again, this one, because there's a reverse reaction, will become a base to that acid to give us these reactants. But now going to step 3, it then becomes the acid to react with water. So I want to these two, they play 2 roles, and these two, they also play 2 roles. So yes, H2PO4 and HPO4 become ampholites. These two become the ampholites. Waikwisha. All right. Then the next question is, write down one conjugate acid base pair for step 2. Do we know what a conjugate acid base pair is? Yes or no? Thumbs up for yes, thumbs down for no.
Any conjugate
Acid base pair. So
I think it's when the acid is a proton, then it's conjugate base form.
okay. I think this is something we didn't get to discuss in our class, but it's good that we get to discuss it now. So we're gonna start with an example before we answer this question. So if we look at the reaction between hydrochloric acid and ammonia, and these are in aqueous form, this gives us NH4 plus chlorine, and these are okay. So our acid, yes. Oh, Jamboard, next slide. Yes, thank you, Go Notile. Thanks for that, ne? Yeah. So we're gonna start with an example. This is not the answer to the question paper, but it's just an example so we understand the idea, ne? Understand the idea. I just want us to understand the idea. So this HCl, ne, is an acid. So let's make the acids in blue. We'll make the acid in blue, ne? So when we look at what happens to each of the reactants, then hydrochloric acid, refer the chlorine ion, which is also an aquatic. And when we look at the base, ammonia, NH3, refer NH4 plus, which is aqueous, ne? So we see that HCl is the acid and NH3 is the base. But now, what happens when if we have, okay. Which is why there is that symbol. You remember that symbol? Two arrows going in opposite directions. You remember? But I hope you like that sign.
Yeah.
All right. So, if we look at the reverse reaction, which is NH4 plus Cl minus, ne? It's going to, if we look at the reverse reaction, then this becomes true. Let me make this one green. And let me make this one yellow. So this is the yellow reaction. Or the green reaction. Ooh, okay. Maybe not. So the long story short, if we're looking at this reaction, then HCl plus NH3 gives us NH4 plus Cl minus, ne? All right, but also NH4 plus Cl, these give us ammonia and hydrochloric acid, ne? And what does this tell us? So if you look at these ones that have different colors, ne? These ones that have different colors. When we look at these two, do you see what goes on? They tell us that the blue ones, ne? These two are a pair. And these two are also a pair. Why one?
Yeah.
So this one becomes an acid, but this one is a base. And this one is an acid, but this one is a base. So when we identify them like this, what does this tell us? These two are a conjugate, ne? Conjugate pair. So this is a conjugate acid base pair, ne? Similarly, they are also a conjugate acid base pair, ne? And right, the important thing about them, understanding this concept will help us answer this one. So back to this slide, ne? The question from the question paper was to write down one conjugate acid base pair for step 2, ne? Step 2 ne? Step 2 is just this one, ne? This is step 2 in this reaction. So we need to look at which one becomes the acid and what's its conjugate base pair, and which one is the base and what's its conjugate acid pair. And now, because we've identified H2PO4 minus as an ampholyte, meaning in step 2 it starts out as an acid, then its result becomes a base. So those two become a conjugate pair. Why one? Therefore, check it over base and acid. So ever acid base pair yabobedi. Then to answer the question, we will have so this is answer, ne? So the answer then becomes, then the H2PO4 minus and the HPO4 2 minus is pair 1, and the H2O and H3O plus is pair number 2. So any one of these two gets you 2 marks. Ne? Yes.
So it's not really necessary. Is it really necessary or only like common knowledge? Rena mineral na ya, kamu harus coy na utiari. There is for example, it's like yeah, for example like yani usul kia, naman na kamu example ya hydrochloric acid and what.
Yeah, this one. These ones. These two.
Yeah.
Are you asking if this or Amy Kwibidule blue?
Yes.
Are you asking if they are necessary?
Yeah.
Oh, okay, that's a good question. I would say they are not necessary. Ne? Now I'm just using them here so that we can visualize, we can see the idea that is conjugate acid-base pair. Wangwisha. Yeah, so I'm using different colors so that you and I can identify and discuss. As we are discussing, so that we can see how we can identify. Agree, in this case, this was the acid, so we identify it. But now it results in a base, which is this one. So those two become the pair, because in the reverse reaction, when this one donates a proton and donates it to that one, then this one goes back to being acid. So I want to show that thing. So I associate the acid with its conjugate base pair, got one color, and I associate the base here with its conjugate acid pair, got a different color, so that it's not confusing. So it's not necessary to draw these arrows. It's not, but it's just for me and you when we are discussing, so that we can see. Waigusha.
Oh, okay.
Yeah. So don't be overwhelmed or it's necessary or you think you'll get marked. No, don't worry about that. For us here, it's just for discussion. I agree, you and I were discussing. Yeah, so because we are discussing, I just want it to be easy so that the conversation is more clear. All right. So the last question here, question 7, is 7.2, ne? And we must complete the following reactions, ne? So the first reaction in 7.2.1 is acetic acid plus sodium hydroxide. And then the second reaction is hydrochloric acid plus calcium carbonate. Ne? Do you know how to calculate these reactions? Hey. Oh, let me new slide. Yes, these ones. We must complete these reactions. That's what we are asked to do. Ne? We are asked to complete these reactions. Right. So how would you go about doing them? Okay, balance around these reactions. Yes, okay, balance around this reaction. You're not sure? Not really. That's okay. So this one, remember when acids and bases react, they give us a salt and water. You remember that, ne? When acids and bases react, they give us a salt and water, ne? So because this one is a typical acid and base reaction, so this is acid, this is base, they should give us a salt and water. So because this one is not very straightforward, ne, I'll just give you a hint, because this one in organic chemistry you'll understand better how it will work, ne? But the long story short is that it gives the following product. And it also gives water, ne? So when we check for balance, we've got 1 sodium on either side. We've got 1, 2, 5 hydrogens on the right. So it's 1, 2, 3, 4, 5 hydrogens on the left. So the hydrogens balance. And then we've got 1, 2 carbons on the right and 1, 2 carbons on the left. So this one would be marked as 3 marks. So here, when you balance it, you'll get 3 marks like that, ne? But because it's an organic compound, this one, it's not very straightforward like an inorganic compound, like in this case here, the second question. But the long story short, because it's an acid, it is a proton donor, so it will give away a proton. But now the base will be a proton receiver. So if it receives a proton, then it will receive that hydrogen, and that hydrogen will give us 2 hydrogens and an oxygen, which gives us H2O. And then the sodium will then be exchanged for the hydrogen. So in other words, you will have, I would love to draw the organic molecules, but you'll learn it better in grade 12. And then in the second reaction, do you think you can try that one? Okay, look at number 2.
Number 2.
Yeah. It's an acid plus a carbonate, which acts as a base in this case. Eh?
Let me try it.
Okay. You can try it. You can try it. Are you getting there? Yeah, pass. Is it passing?
Yeah, but it's not mixed.
Does not make sure. Okay. Call out for me what you got on the right hand side. Then we're gonna correct it. So what were your products? Mm-hmm. 3HCl. Eh? No, Mpileche, just the products. What we will get on this side. What we will get this side. What will it be? Let's start there. Mm-hmm. CACL. Okay. Uh-huh.
Carbon dioxide.
Okay, good. Plus?
H2O.
Plus H2O. Okay. Up to so far, ne? I'm sure maybe you will get 1 mark or 1.5 marks for identifying these 3. You are correct. These 2 definitely 100%. But you must remember, calcium, ne? It's on group 2, ne? Calcium is on group 2. That means it is willing to receive, or rather to donate 2 protons. Yeah? So metals that are in group 2 would donate 2 protons. Or is that the correct use? Someone will correct me. But the point is, for it to form a stable molecule, for calcium to form a stable molecule, it must have its 2 valence protons be balanced out by 2. Its 2 valence electrons be balanced out by 2 electrons. So chlorine towards it. So that's the only thing you didn't do correctly so far when identifying the products. Then now we're going to balance this, ne? So for calcium chloride to exist stably, we will need 2 chlorines, ne? So if we're going to need 2 chlorines, it's fine. That means we should have 2 hydrochloric acid. Also, the 2 hydrochloric acid is important because the 2 hydrogens will combine with the 1 oxygen from there to give us H2O. And when we take out 1 oxygen there and it forms the H2O, then the carbon dioxide is left and it can be balanced there on its own. So the correct then balanced equation will therefore be CaCl2 plus carbon dioxide plus H2O. And on the reactant side is only 2 hydrochloric acid plus 1 calcium carbonate. Why kushisha? Okay. So I want us to end here, ne? So that I can upload this video and hopefully you'll be able to watch it before Ngwalaka Osani, ne? Is there anything you want to ask before we conclude? Is there anything on your buchisha before we get to la class for tonight? No. Okay. So it's fine. Just one more remark. Both these questions are 3 marks each. And this type of question would be about 14 marks. 2, 4, 6, 8 plus 6. Yeah, question 7, it's about 14 marks.
Oh, okay.
Yeah. So I suspect for tomorrow's exam, if Lingola just chemistry, it's just going to be a short test really. So it will be that 14 marks for this acid-base reaction, and maybe another 19-20 marks for those gas laws, Boyle's law, etc. And yeah, but if you include the physics part, you will probably write about what's this? You'll also probably write about electricity, and you'll also write about the relationship between current and potential difference, so Ohm's law. And yeah, I think that will be it, as if you write both physics and chemistry in one test. So please kgopela o revise just a little bit here, or just watch the videos from electricity that we've done. And then also, if you can go through some of the handwritten notes on Classroom, like I've shared here. If you see here, we've got these ones, rate and extent of reaction. So you'll find some valuable notes there for acids, bases, etc., as well as chemical equilibrium. And then for electricity and electric circuits, we've got Ohm's law, we've discussed here. It's also there, ne? So you'll find it there. So just prepare yourself, go through the notes, odibale, just to revise the concepts. If you can, watch the videos, and then yeah. Any other question? You are satisfied?
Yeah.
All right, I'm glad. Then I'll see you tomorrow for math class, ne?
Okay, bye.
Good night.